Hello and welcome to Algebra 1, Lesson 10. In this video, we're going to learn about proportions. So before we get into proportions, let's recall that a ratio is a comparison of two quantities. So one way you might see this written, let's say you had the ratio of A to B. You might see it written with a colon. So you might see A and then a colon and then B. So this is the ratio of A to B. You also might see it written with the word to. So you might see A to B. And then lastly, you might see it written as a fraction. So you might see A over B. So each of these would be a different method to display the ratio A to B. All right, so as a quick example, let's think about the ratio of boys to girls in a classroom. So suppose there are 12 boys and 3 girls. So the ratio of boys to girls looks like this. You have 12 boys, and you have 3 girls. So you can put 12 to 3 like that. You could put 12 colon 3 like that. Or you could put 12 over 3. Now remember, a ratio can be reduced to its lowest terms, the same way you would reduce a fraction. So you look at kind of the first part, the part that would be in the numerator, and you look at the last part, the part that would be in the denominator, and you say, hey, what's my greatest common factor? So when we look at 12 and we look at 3, the GCF would be 3. So if I divide 12 by 3, I get 4. If I divide 3 by 3, I get 1. So the ratio of 12 to 3 can be simplified and thought of as the ratio of 4 to 1. Now, a lot of times, I know when we're working with fractions, we might get rid of this 1. We might just write that as the number 4. When we're working with ratios, we don't do that. So if I have the ratio of boys to girls, I want to say it's 4 to 1. I don't want to just say it's 4, right? So you want that 1 there. It's very important when you're working with a ratio to just leave it there because you're talking about a comparison of one thing to another. All right, let's talk a little bit about a rate. So a rate is also a ratio, and this is one in which the units are different. So the units are different. So typically we see these as unit rates, okay, unit rates. And every time you go into a grocery store, you're going to deal with this. If you look at the little grocery labels, next to the price, it'll probably say this is the price per ounce or this is the price per pound, so on and so forth. So how much of something per 1 unit of another. So you can think about a car drove 300 miles on 6 gallons of gas. You can use this information to set up a unit rate and figure out the miles per gallon here. So 300 miles, put that in the numerator, and then I'm going to put 6 gallons of gas in the denominator. So we have 300 miles per, you can think of your fraction bar as saying per, 6 gallons of gas. And we could simplify this by looking at the numbers. If I divide 300 by 6, I would get 50. So I would write 50, and the units are going to stay there, miles per, and then if I divide 6 by 6, I'm going to get 1. So 1 gallon of gas. So 50 miles per 1 gallon of gas. And that's very, very common. We're always thinking about our fuel economy. So what is the number of miles I'm going to get per gallon of gas, on average? So if you do a road trip, you can track how many miles you do and on how many gallons of gas, and you can set up the same thing. You can figure out your miles per gallon. And one thing about a unit rate, you're going to notice that the units do not cancel. So with a typical ratio, we have the same units, and so we really don't list them, right? You don't need to because you could think of them as kind of canceling out. Here I have miles in the numerator, and I have gallons of gas or gallon of gas in the denominator. So those we're going to write, right, for clarity. But they don't cancel out, so we just keep them there. And basically the only thing you need to understand is you're always going to take the number in the numerator, which in this case is 300, and divide it by the number in the denominator, which there is 6. That's going to give you some amount in the numerator per 1 amount in the denominator. So it's always per a single unit. You always want a single unit in the denominator. That's why it's called a unit rate. So let's take a look at another one real quick. So 12 eggs purchased for $3.60. So I can put $3.60 in the numerator, and I can put per 12 eggs in the denominator. And what I'll do is I'll divide this $3.60, or just 3.60, by 12, and I'm going to get a unit rate, which is a cost per one egg. So if I divide 3.60 by 12, I get 0.3. So I would get $0.3 per one egg. Right? So this is the unit cost, right? The cost per one egg. And again, I take the number part from the numerator and I divide it by the number part in the denominator, and that's going to give me my unit cost. So this denominator will always be singular. So instead of eggs, it becomes egg. And then the numerator, whatever number you end up with, it's going to be the value per one unit. So again, this is a single unit. And that's why we call it a unit rate. All right, so now that we've kind of reviewed the basics of what a ratio is, let's talk a little bit about a proportion. So we talked about this in pre-algebra. A proportion states that two ratios are equal. And a lot of times we're just looking at two fractions, right? And we're trying to see if those two fractions are equal. And if they are, we say that we have a proportion. So I want you to recall that we can determine if there's a proportion by using the equality test for fractions. The equality test for fractions. How do we do the equality test for fractions? It's very, very simple. I take the denominator of one fraction and I multiply it by the numerator of the other. So 4 times 2 is 8, and I look at that value. I then take the denominator of the other fraction and I multiply it by the numerator of the other fraction. 8 times 1 is 8. If I get the same value on each side, then the fractions are equal, or you could say the ratios are equal, however you want to think about it. And so you have a proportion. So yes, this is a proportion. And it's important to note that this is called cross multiplying. So it's always going to be the denominator of your first fraction times the numerator of the second one, and then the denominator of the second one times the numerator of the first one. Let's take a look at this one. We have 3/8 and 4/7. We want to know if we have a proportion. So again, we're going to cross multiply. So I would take the denominator of this fraction here, multiply it by the numerator of this fraction here. So 8 times 4 is 32. Then I'd take the denominator of this fraction here, and I'd multiply it by the numerator of this fraction here. 7 times 3 is 21. So we do not have the same value. 21 is not the same as 32. So this is no, it's not a proportion. Again, in order to have a proportion, this times this has to be the same as this times this. Have to get the same value. So before we kind of move on to solving a proportion equation, I want to kind of cover something you're going to see in your textbook. So you're going to see that if A over B is equal to C over D, then it must be true that AD is equal to BC. So what they're doing is they're cross multiplying. They're saying, okay, B times C is BC. And that has to be equal to D times A, which is AD, or DA, or however you want to write that. It doesn't matter. Now, you might think about, where did this cross multiplication come from? Well, if I kind of look at the denominators here, I have B and I have D. So let's say I multiplied both sides of the equation by the LCD, which is BD, right? B times D. If I multiply this side by BD, which is perfectly legal with an equation, as long as I do it to this side, we see here that this would cancel here, and we also see that this would cancel here. So what would I have left? I'd have D times A, which is the same as AD, right? I just switched the order. And this is equal to C times B, or BC, right? So if I multiply both sides of the equation by the LCD, I end up with this right here. This is kind of just a shortcut, right? I'm multiplying this by this, and I'm multiplying this by this, because the other part is going to cancel out. So I end up with AD equals BC. So we're going to be using this logic to solve a proportion equation. So here we have 4 over 7 equals 2 over x. Now, in order to solve for the unknown in a proportion equation, we just remember that if it's true that 4/7 equals 2 over x, that 7 times 2 which is 14, 7 times 2, has to be equal to x times 4, or 4x. Otherwise, we can't put an equal sign here. So knowing that, I just cross multiply and set up an equation like I did here. This just becomes 14 is equal to 4x. And we simply solve for x. We divide both sides of the equation by 4. And we end up with 7 halves. Right? If I divide 14 by 2, I get 7. If I divide 4 by 2, I get 2. So 7 halves equals x. Or in decimal form, you could write 3.5. But typically, if I'm working with fractions or ratios or however you want to think about that, if I'm working with that, I want to stay with that. I don't want to switch to decimals. So I get x equals 7 halves, or I have 7 halves equals x. It doesn't really matter how you say that. And to check it, you just plug it in. I just plug in for x. So what would I have? I'd have 4/7 is equal to 2. Remember, I could write 2 as 2 over 1, divided by this x, which is 7 halves. And then it makes it obvious that I'm going to end up what? I'm going to take 2 over 1, and I'm going to multiply by the reciprocal of 7 halves, which is 2 over 7. 2 times 2 is 4 over 1 times 7, which is 7. So this becomes 4/7 as well. So we get that 4/7 equals 4/7. Both sides are the same value, and so we know our solution, x equals 7 halves, is correct. All right, let's take a look at another one. We have 7 over y equals 4/8, or 4 over 8. So again, I'm going to cross multiply and set up an equation. Y times 4, which is just 4y, has to be equal to 8 times 7. 8 times 7 is 56, or I can write 8 times 7 and do it in 2 steps. So that's the first thing, just cross multiply, set up an equation. So then we have 4y is equal to 56, right? 8 times 7 is 56. And then we just divide both sides of the equation by 4, the coefficient of y. 56 divided by 4 is 14. So we get 14 here. So y equals 14. All right, so if I plug in a 14 for y, you can mentally see that that's going to work out, right? Because 4 is half of 8 and 7 is half of 14. So if I reduce each, if I divide 4 by 4, I get 1. If I divide 8 by 4, I get 2. Right? So if I think about this, just as taking the fractions and simplifying them, 4/8 is 1/2. 7/14 is also 1/2. Right? If I divide 7 by 7, I get 1. If I divide 14 by 7, I get 2. So 1/2 equals 1/2 is what you'd end up with. And so y equals 14 is the correct solution. All right, now we want to take a look at x over 2 equals 7/6. So again, I'm just going to cross multiply and set up an equation. So 2 times 7 is 14. 14, and that equals 6 times x, that's 6x. All right, so once we've set up the equation, we just divide both sides of the equation by the coefficient of x, which is 6. That will cancel with that and just leave me with x. What is 14 divided by 6? Well, I can use a decimal, which, again, if I'm working with fractions or, again, ratios, I just want to keep it in that form, make it nice and simple. So I'm just going to simplify this since I wouldn't get a whole number. Each is divisible by 2. So this divided by 2 is 7. This divided by 2 is 3. So x is going to equal 7/3. And again, plug in for x there. So I'd have 7/3 divided by 2. So divided by 2. And again, for the purpose of working with fractions, we'll say divided by 2 over 1. And so I know that that's basically 7/3 times the reciprocal of 2 over 1. So it's 7/3 times 1/2. 7 times 1 is 7, which is what I have up here. 3 times 2 is 6, which is what I have here. So I would get 7/6 on the left as well as on the right. So again, x equals 7/3 is my correct solution. All right, let's take a look at one that's a little bit harder. And by harder, I just mean more tedious. So we have 5 over 3 is equal to k minus 2 over k minus 7. So I'm doing the same thing. I'm going to take 3 and multiply it by this side. Now, very, very important here. I am multiplying 3 by this whole quantity. So I need to use parentheses around that quantity. I need to say that 3 is going to be multiplied by k minus 2. If I just put 3k minus 2 like that, I'm wrong because I didn't multiply 3 by 2, right? So I need to make sure that 3 is multiplied by each term here. And to do that, again, I use parentheses. So 3 times the quantity k minus 2 is equal to, I'm going to have this value multiplied by this. So 5 times the quantity k minus 7. Again, you got to use parentheses. You're multiplying 5 by k and by negative 7. So you use parentheses for that. Please don't make that mistake of not putting parentheses and not multiplying that number by each term. Very, very common, and it will cost you an answer on your test. All right, so now we simplify. So 3 times k is 3k, minus 3 times 2 is 6, and this equals 5 times k is 5k, then 5 times negative 7 is negative 35. So now this is pretty easy to solve. I'm going to subtract 5k away from both sides. That way I just have a variable term on the left, nothing on the right, so this will go away. And I'm going to end up with, I'm just going to kind of drag this over here, 3k minus 5k is negative 2k. And then minus 6 equals negative 35. I want to isolate this on one side of the equation. So I'm going to add 6 to both sides. So this is gone. And what I'm left with over here is negative 2k. And on the right, negative 35 plus 6 is going to be negative 29. Okay, so continuing, I want k by itself, so I just divide both sides of the equation by negative 2, the coefficient of k. That cancels with that. I have k over on the left. On the right, I have negative 29 divided by negative 2. And 29 is a prime number. I would just leave it as 29 over 2. Right? Negative divided by negative is positive, so you can remove the negative signs and list that it's positive, but you really can't simplify it any further. Now, checking this will be a little tedious, but we want to do it anyway. All right, so I would have 5/3 equals, we have 29 halves minus 2. And I'm going to go ahead and write 2 as 4 over 2. So I have a common denominator. And then this is over. Again, for k, we have 29 over 2. And then minus, we have 7. I'm going to go ahead and write that as 14 over 2. Again, so I have a common denominator. So this is basically what? A complex fraction over here. We already know how to simplify a complex fraction. Essentially, there's 2 different ways. We could multiply the numerator and the denominator of the complex fraction by the LCD, which would be 2. Or we could just simplify the numerator and denominator separately. So I think it would be a little faster if we multiply the numerator and denominator here by 2. So let's do that. So I'm going to multiply this by 2, and I'm going to multiply this by 2. Now, you might be thinking, oh, this is an equation, so I got to do this to the other side. No. Remember, if I multiply a fraction by the same number top and bottom, I don't change the value of that. I'm multiplying by 2 over 2, which is just basically I'm multiplying by 1. If I multiply by 1 over here, I can multiply by 1 over here, but multiplying by 1 doesn't change the value of something. So I don't need to do that to both sides. I just need to do it to this side. This 2 is basically going to be distributed to this, and it would cancel this 2 here, and then to this, and it would cancel this 2 here, so that's gone. Same thing over here. It would be distributed. This cancels when it gets over here, so that's gone. So I can kind of erase the denominators here because they would completely go away. So this is gone. And essentially I'd have 29 minus 4, which is 25. So I could write this as 25. And then over 29 minus 14, which is 15. Now I can simplify this and make it look like this. 25 is divisible by 5. 25 divided by 5 is 5. 15 is divisible by 5. 15 divided by 5 is 3. So when I simplify 25/15ths, I end up with 5/3. So you get 5/3 equals 5/3. So yeah, our solution k equals 29 halves is correct. All right, let's take a look at another one. We have 7/8 equals v minus 7 over v plus 4. So again, set up your equation. 8 times this quantity, v minus 7. Again, have to use parentheses here. So I'm going to put 8 times the quantity v minus 7 is equal to this quantity, v plus 4, times 7. So again, I got to use parentheses. 7 times the quantity v plus 4. Again, 8 has to be multiplied by v and by negative 7. right? Don't just do this. Don't just say, okay, 8 times v minus 7. That doesn't work. So 8 times v is 8v minus 8 times 7, that's 56. And this equals 7 times v, that's 7v, plus 7 times 4, that's 28. All right, so I'm going to move my number to the right here, move my variable term to the left, okay? And I'm going to do that in one step. So I'm going to add 56 to both sides of the equation. That way there's no longer anything other than a variable term on the left. And I'm going to subtract 7v from both sides of the equation. That way there's no longer a variable term on the right. So on the left now, I have 8v minus 7v, which is just v. On the right, I have 28 plus 56, which is 84. Okay, so v equals 84 is our solution here. All right, so we have 7/8 is equal to v minus 7. And again, v is going to be 84. So 84 minus 7 over v plus 4. So again, 84 plus 4. And so we'll have 7/8 over here. What is 84 minus 7? Well, that's going to be 77. What is 84 plus 4? That's going to be 88. So each here is divisible by 11. If I divide 77 by 11, I get 7. If I divide 88 by 11, I get 8. So 7/8 equals 7/8. And so v equals 84 is the correct solution. All right, let's take a look at another one. We have negative 3/6 equals x minus 5 over 2x plus 2. So again, I'm going to set up my equation. So 6 is going to be multiplied by this quantity, x minus 5. Again, you have to use parentheses. So 6 times the quantity, x minus 5. This is equal to, now I'm going to take 2x plus 2, multiply it by negative 3. Okay, so negative 3 times this quantity, 2x plus 2. Again, you have to use parentheses. You might want to put that next to each problem like a big star so that it just gets into your head that I have to use parentheses when I'm multiplying a single number times a quantity. So 6 times x is 6x. Then minus 6 times 5, that's 30. This equals negative 3 times 2x, that's negative 6x. Then negative 3 times 2 would be minus 6. All right, so I am going to add 6x to both sides of the equation. And I'm also going to add 30 to both sides of the equation. So this will go away, and so will this. And what will I have left? 6x plus 6x is 12x. Negative 6 plus 30 is 24. Divide both sides of the equation by 12, the coefficient of x. And we get x is equal to, 24 divided by 12 is 2. So we have negative 3 over 6 is equal to, up here I'm going to plug a 2 in for x, so I'd have 2, and then minus 5 up here, and then down here I'd have 2 times x, so 2 times 2, and then plus 2. So I'd have negative 3 over 6 is equal to, 2 minus 5 is negative 3, then 2 times 2 is 4, plus 2 is 6. So we get negative 3 over 6 equals negative 3 over 6, and if we wanted to, we could reduce this to negative 1/2 in each case, right? This would divide by 3 and become 1. This would divide by 3 and become 2. Same thing over here. So we could have negative 1/2 equals negative 1/2. But you could also leave it as negative 3/6 equals negative 3/6. The main point is that your solution here, which was x equals 2, is correct.